Imagine a world where the brains behind supercomputers, those massive computation hubs, are designed and built right here in Europe. That's exactly what a project called DARE is aiming for. We've got a great article from the Register all about it, published just last week on March 7th.
Okay.
Today, we'll unpack Europe's ambitious plan to use a technology called RISC-V to achieve supercomputing sovereignty.
Yeah, what's really interesting here is that Europe has been, dipping its toes into RISC-V for a while now.
Right.
But this project, DARE, which stands for Digital Autonomy with RISC-V in Europe, is a huge leap forward.
Okay.
They're not just experimenting anymore. They're putting serious money where their mouth is to the tune of $240 million.
Wow, and it's not just about the money. 38 different tech players across Europe are teaming up.
Right.
Which shows just how serious they are about this.
Exactly.
It's a stark contrast to their first exascale system, which relied heavily on ARM technology.
Yeah, you hit the nail on the head there. It really highlights Europe's desire to control its own technological destiny.
Okay, so let's break down this RISC-V thing.
Sure.
For those of us who don't speak fluent computer, what is it and why is Europe so excited about it?
So imagine a blueprint for building a computer processor, but instead of being closely guarded by one company, it's open source and royalty-free.
Okay.
Anyone can use it, tweak it, build on it without having to pay hefty licensing fees.
Got it.
That's RISC-V in a nutshell.
So it's kind of like the Linux of processor design.
That's a great analogy.
Yeah.
And just like Linux shook up the operating system world, RISC-V is poised to do the same for processor design.
Right.
It's a real opportunity for Europe to break free from its reliance on US-based chip designs and build a supercomputing ecosystem on its own terms.
I'm starting to see why they're calling this technological sovereignty.
Yeah.
It's like they're saying, we can do this ourselves and we're going to do it better.
Exactly, and they're not alone in this pursuit. Other countries like India and China are also jumping on the RISC-V bandwagon, seeing it as a way to reduce their dependence on Western technology.
It's spreading.
It is.
So this DARE project, how are they actually planning to use RISC-V to build these supercomputers?
They've got a pretty ambitious 3-year plan to develop 3 RISC-V chiplets.
Okay.
Think of these chiplets as specialized Lego blocks,
Okay.
each designed for a specific task that can be combined to create larger, more complex processors.
Okay, I'm picturing a Lego supercomputer now. That's a helpful image.
Yeah.
So what are these different chiplets?
The first one is a vector math accelerator designed for crunching massive amounts of data.
Okay.
It's the powerhouse behind scientific simulations, complex financial modeling, weather forecasting, that kind of thing.
Got it.
Leading the charge on this is OpenShip, a company based in Barcelona.
Okay.
Mm-hmm.
And then there's a next generation inference chiplet, which I'm guessing is all about AI.
You got it.
Okay.
That's being developed by a Dutch startup called Accelera AI, and they're focusing on creating chips that can handle the intense processing demands of artificial intelligence.
And the third chiplet.
That's the general purpose processor, the brains of the operation, if you will.
Right.
It's designed to handle a wider range of computing tasks and is being spearheaded by Codicip, a company based in Germany.
So 3 chiplets, 3 different companies, all working together to create a European-made supercomputer.
Yeah.
It's quite the collaboration.
It is, and each company brings something unique to the table.
Yeah.
Accelera AI, for example, has already made a name for themselves with their innovative AI chips.
Oh, yeah. I remember reading something about their chips using a special kind of in-memory processing,
Right.
which is supposed to be incredibly efficient.
That's right. They store the data right inside the processing units, which makes the calculations lightning fast and uses way less energy.
Wow.
It's actually a similar approach to what Google uses in their TPUs, those super powerful AI chips that have been making waves.
So Accelera is kind of like a David taking on the Goliath of Google.
In a way, yes, and they're definitely holding their own.
Okay.
Their current chips can already achieve over 200 INT8 TOPS.
Okay. You lost me there. 200 INT8, what now?
Right?
Can we translate that from computer speak to human speak?
Of course, INT8 TOPS basically measures how many trillions of operations a chip can perform per second.
Okay.
200 is a huge number. That's the kind of processing power you need for things like recognizing complex patterns in medical images, training AI models to understand natural language, or even creating realistic virtual worlds.
So basically really powerful stuff that could have a real impact on things that matter to people.
Exactly. And what's even more impressive is that these chips can achieve that level of performance while only using 15 to 20 watts of power.
Wow.
That's less than a light bulb.
That's pretty incredible. It seems like they're really pushing the boundaries of what's possible in chip design.
Hmm.
And their next chiplet, Titania,
Mm.
is going to take this even further, right?
That's the plan. Titania is designed to scale up their technology for even more demanding server-grade workloads.
Okay.
We're talking about the kind of heavy lifting needed for large-scale AI applications, big data analysis, and of course, supercomputing.
It sounds like Axelera is leading the charge in this whole RISC-V revolution.
They are.
But what about Codasip, the company working on the general purpose processor?
Yeah.
What are they bringing to the table?
Well, Codasip is a bit of a different story. They've already got a whole portfolio of RISC-V CPUs that are being used in a variety of applications, from network edge devices and IoT sensors to smaller computers.
So they're kind of like the RISC-V veterans.
Exactly. They've got a lot of experience under their belt, and with this DARE funding, they're looking to leverage that experience to break into the high-performance computing market.
Okay.
Think AI, big data processing, and yes, even supercomputing.
So it's almost like they're taking RISC-V to the big leagues.
That's a great way to put it. They see a huge opportunity to use RISC-V to compete with the established players in the high-performance computing world. And DARE is giving them the resources to make that happen.
It's really interesting to see how both Axelera and Codasip are using RISC-V in such different ways, each playing to their strengths.
Right.
It speaks volumes about the versatility of this technology.
I completely agree. It's like they're both exploring different facets of the same diamond, uncovering new possibilities and pushing the boundaries of what's possible.
So we've got Axelera pushing the boundaries of AI processing with their super efficient chips, and Codasip aiming to take RISC-V to the big leagues of high-performance computing.
Yes.
It's a powerful combination.
It certainly is. And then, of course, we have OpenChip working on the vector math accelerator, which, if we're being honest, remains a bit of a mystery.
You're right. There's not a lot of information out there about their project.
Yeah.
It's almost like they're playing their cards close to their chest.
Exactly, which makes you wonder what they're cooking up over there in Barcelona. Perhaps they're working on something truly groundbreaking that they're not quite ready to reveal just yet.
I guess we'll have to wait and see.
Yeah.
It definitely adds an element of intrigue to the whole DARE project. But
Yeah.
speaking of intrigue, there's another layer to this whole story that we can't ignore.
You're talking about the geopolitical angle.
Exactly. This
Yeah.
whole push for RISC-V in Europe isn't happening in a vacuum.
Right.
It's like this whole RISC-V thing is a piece of a much larger puzzle, and that puzzle is the global technology landscape.
You're absolutely right. We're in the midst of this fascinating technological power struggle, primarily between the U.S. and China.
Right.
And RISC-V has become a key player in this game.
It's interesting because RISC-V is open source, so in theory, anyone can use it.
Right.
But it seems like some people are getting a little nervous about who anyone might be.
Exactly. There's been a lot of talk in the U.S., particularly among lawmakers, about China's growing interest in RISC-V. They're worried that China might use this open technology to gain an edge in strategically important areas like supercomputing and artificial intelligence, potentially surpassing U.S. capabilities.
So it's kind of a double-edged sword. On the one hand, you have this amazing open technology that has the potential to level the playing field. And on the other, you have concerns about how that same technology could be used to disrupt the current balance of power.
It's a classic dilemma in the world of technology. It raises all sorts of questions about how to encourage innovation while also safeguarding national interests.
And how does Europe's gamble on RISC-V fit into this whole geopolitical chess game?
Well, for Europe, DARE is more than just about building faster computers. It's a strategic move to assert their technological independence and avoid becoming collateral damage in this U.S.-China tech rivalry.
So they're trying to carve out their own space, a sort of third way in this increasingly polarized tech world?
Precisely by investing in RISC-V and fostering their own supercomputing ecosystem, they're reducing their reliance on both American and Chinese technology. It gives them more control over their own technological future and a chance to play a leading role in shaping the development of this transformative technology.
It's almost like they're saying, hey, we're here too, and we have something valuable to contribute.
Exactly. And it's not just about supercomputing. The potential applications for RISC-V are vast.
Yeah.
We're talking everything from the smartphones in our pockets and the laptops we use every day to the cars we drive, the networks that connect us, and even the spacecraft we send into space.
So if Europe can really position itself as a leader in the RISC-V ecosystem, the implications could be huge.
Absolutely. Imagine a future where Europe becomes a global hub for RISC-V innovation and development, attracting the best and brightest minds from around the world.
Wow.
They could set standards, drive new applications, and create entirely new industries based on this technology.
That's a pretty exciting vision. But let's be realistic. There have to be challenges too, right? It's not like Europe is just going to waltz in and take over the tech world overnight.
Of course, there will be challenges. Building a robust RISC-V ecosystem is a long-term game that requires sustained investment collaboration and a willingness to take risks. One of the biggest hurdles they'll face is attracting top talent. The US and China are already pouring enormous resources into attracting the best engineers and researchers in the field. Europe will need to step up its game to compete on that front.
It's like they're trying to build a brand new house in a neighborhood where everyone else already has a mansion.
That's a great way to put it. And they'll also need to overcome the inertia of existing systems. Right now, the world of high-performance computing is dominated by established players with deep roots and well-established supply chains. Breaking into that market won't be easy.
So they're facing a talent crunch and a market dominated by giants. What else?
Another challenge is going to be creating a unified European approach right now. A lot of the RISC-V development is happening in individual countries, with different companies pursuing their own agendas to really succeed. Europe will need to foster greater collaboration and coordination across national borders.
It's like they're trying to build a supercomputer, but they also need to build a super team to do it.
Exactly, and that requires overcoming political differences, navigating complex regulations, and finding ways to effectively share resources and expertise. It's a tall order, but the potential rewards are enormous.
It sounds like this DARE project is just the tip of the iceberg, the first step in a much larger journey for Europe.
I think that's a great way to look at it. Whether or not they ultimately succeed remains to be seen, but one thing's for sure. They're making a bold bet on RISC-V and putting their money where their mouth is. And in the world of technology, that's often where the most exciting innovations happen.
It's definitely a story worth watching. So to recap, we've got this ambitious European project called DARE, aiming to build supercomputers using RISC-V. This is open source technology that's shaking up the global tech scene.
We've talked about how this project is not just about building faster computers, but also about asserting technological independence and carving out a space for Europe in a world increasingly dominated by US-China tech rivalry.
We've also explored how RISC-V is enabling smaller companies like Accelera AI to compete with giants like Google.
Right.
And how more established players like Codicip are leveraging this technology to push into new markets.
Exactly.
It really does feel like we're witnessing a pivotal moment in the evolution of computing. I mean, what if RISC-V really does take off and becomes the dominant architecture?
Yeah.
What would that mean for the future of technology?
That's the million-dollar question, isn't it? It's certainly a possibility. The open nature of RISC-V combined with its flexibility and efficiency makes it a very attractive option for a wide range of applications.
So instead of a world dominated by a handful of tech giants, we could see a more diverse and decentralized landscape with more players at the table.
Exactly. It could foster greater innovation, lower barriers to entry, and lead to the development of new and unexpected technologies that we can't even imagine yet. It's like opening up a whole new box of Lego blocks and seeing what people can create.
I like that analogy.
Yeah.
And it's not just about the technology itself, it's about the values that it represents.
Right.
Openness, collaboration, accessibility. Those are pretty powerful ideas.
They are indeed. And if those values become embedded in the very foundation of our digital world, well, that could have a profound impact on how we live, work, and interact with each other.
Yeah.
It's not just about faster computer. It's about a more equitable and inclusive technological future.
It's inspiring to think about the possibilities, but I also can't help but wonder about the potential downsides.
Sure.
I mean, every technology has its risks, right?
Right.
What could go wrong with RISC-V?
You're right to be cautious. No technology is a silver bullet, and RISC-V certainly has its challenges. One concern is security, with so many different players involved in its development. Ensuring the security and integrity of the architecture is a complex task.
Like a house with 1,000 doors, you need to make sure they're all locked.
Exactly. And then there's the issue of fragmentation. If everyone is tweaking and customizing RISC-V to suit their own needs, we could end up with a fragmented ecosystem where different versions of the technology are incompatible with each other.
Right.
That could stifle innovation and make it harder to develop truly universal applications.
So there's a need for some kind of governance, some way to guide the development of RISC-V and ensure that it remains open, secure, and interoperable.
Absolutely. And that's something that the RISC-V Foundation, the organization that oversees the development of the architecture, is very much aware of.
Okay.
They're working on establishing standards, fostering collaboration, and creating a framework for responsible innovation.
It sounds like a delicate balancing act. encouraging innovation while also managing the risks. It's going to be fascinating to see how it all unfolds.
It certainly will be, and as we've seen with Europe's DARE project, there's a lot at stake. The future of high-performance computing, the balance of power in the tech world, the very values that underpin our digital society, it's all intertwined with the fate of
And
RISC-V.
it's a story that's still being written, and we'll be watching closely to see what the next chapter holds. But for now, we have to leave our listeners to ponder the implications of all this.
As we've seen today, RISC-V is much more than just a new processor design. It's a catalyst for change, a potential disruptor, and a symbol of hope for a more open and inclusive technological future.
It's a reminder that innovation can come from anywhere, and that sometimes the biggest changes start with the smallest of things, like a simple open-source blueprint for a computer chip.
So as you go about your day, think about the technology that surrounds you, the devices you use, the data that flows through the digital world.
And ask yourself, what role will RISC-V play in shaping that future? And what kind of future do you want to see? The answers to those questions are still being written, and perhaps in some small way we all have a part to play in shaping that story.
Until next time, keep exploring, keep questioning, and keep diving deep into the world of technology.
And who knows, maybe in a few years we'll be back here on the Deep Dive revisiting this topic and seeing how it all played out.